So when you're on a ketogenic diet, you get more energy in the brain, and that allows all kinds of repair, all kinds of focus and cognitive ability.
Amber, again, thank you very much for joining me. I really appreciate it. You've done a number of presentations on why we are carnivores, and so I wanted to touch on how we evolved, and like, for example, did we evolve to eat meat, or did we evolve because we ate meat?
I think it's both. Yeah, sort of co-evolution of our brains and our physiology. Obviously, we had some kind of pre-human ancestor that was not as carnivorous as we are, and we see our closest living primate relatives to be the chimpanzees and gorillas and orangutans, the great apes, basically. And they're obviously much more herbivorous, although they may include a small amount of meat in their diet. It's supplementary more than the mainstay. And you can see that they're herbivores largely because of the way that their guts go. You know, their whole abdominal cage goes out to hold this foregut, or hindgut. They're not foregut fermenters like ruminants, but they're hindgut fermenters, which means they have a whole area devoted to bacteria that will break down fiber, because the main source of their calories comes from fiber.
I've heard you say this before, but these are our closest relatives. But I mean, closest doesn't mean close, right?
Exactly. Yeah. Yeah.
So this is something that gets thrown up at carnivores a lot by, veganers and so on. That we're monkeys, and so we should eat like monkeys do.
Right. Yeah, it's where we're different that makes all the difference. The example I'm sure you've seen me use before is a hippopotamus. The closest living relatives of hippopotamuses are the cetaceans, whales, and dolphins and such, which many of which are completely carnivorous, but yet the hippo is quite herbivorous, and a lot of change can happen between the closest relatives, and like you said, that doesn't necessarily mean we're close. So we had this split, and there was a whole line, some of which the species no longer exist on the line that already split from the chimpanzees, but is going toward what became Homo sapiens. And it's in that line where all of these changes occurred in terms of the amount and pattern of our meat eating, and at the same time the physiological changes that either enabled that or supported that, or I guess both, where we started seeing big changes in our guts and our ability to process fibers, and at the same time we had this big brain expansion. And scientists who study this have pointed out that it's likely to be causal, because both the gut tissue and the brain tissue are extraordinarily expensive to run. The brain it just takes up I think a quarter of our energy all the time, and in order to do that, we had to get a lot more efficient. And the fact that we gave up the ability to process fiber to a large degree means that we were basically stranded into forced into using something much more efficient. And these days, we can use carbohydrates to get energy that is like digestible, highly digestible carbohydrates, where you can get sugar out of them very fast in a way that you can't from those fibrous foods that we depended on earlier. But those kinds of carbohydrates weren't really available until much, much, much more recently. At least they weren't available in any kind of sustainable, reliable sense. They wouldn't have been enough to allow us to grow the way that we grew. And so really the only possibility, well, there's still protein, but we have pretty hard limits on how much protein we can digest without starting to suffer. That would be somewhere around 30, 35 maybe max % of our calories. And it really just leaves fat. And so just from looking at the perspective of what was possible for us to eat based on our physiology and what was available, it pretty much eliminates any other hypotheses that don't involve a high degree of fat from animals.
So you're saying that okay, like the most efficient energy source for our brains, even though now we do have carbohydrates, easily digestible carbohydrates, is that now more efficient than fat though?
I think they're both pretty efficient.
Okay.
In terms of physiology, because when you eat, say, a piece of bread or something, it breaks down pretty fast and gets glucose into your bloodstream really fast. It has a glucose index or a glycemic index that's very high, and that's an indicative of how efficient that is. But it's at the time that we're talking about when all these changes were going on, we wouldn't have had access to those kinds of carbohydrates on a daily basis.
But the glucose from carbohydrates wouldn't last as long either. So it might give us a short burst of energy, but after, in a very short while, you need to keep eating more carbohydrates rather than, whereas fats last longer. Yeah.
Well, that's largely true because what we eat doesn't stay necessarily in the bloodstream. You can't have your blood sugar go too high. Your body will kick in insulin to store whatever can't be used quickly. So now if you eat a bunch of glucose, you've got some that stays in the bloodstream and it's feeding all your cells, and that could be working fine. But at the same time, you get this huge insulin response so that a bunch of it is tucked away, and now you get hungry again much more quickly. Whereas if you're on a ketogenic diet and you're in that context where there's a lot of fat going around in your bloodstream, there's not going to be that same kind of drive to store it and lock it away into your adipose tissue in a way that it can't continue to be accessed. So in between meals, your insulin's pretty low, and your fat tissue is letting out more fats at a rate that allows you to keep up the energy generation that all of your cells need. And as long as that energy generation is going, you're not going to feel the need to eat anything until the levels in the blood of fat, the combination of fat and glucose, get so low that your cells that it's not able to keep up with the rate that your cells want to keep generating energy.
Yeah, like we were talking about, like we evolved because we started eating meat, and from there we evolved quite big. Like the hunter-gatherer, they were quite big in the past. Where are we now? Since the agricultural revolution, I saw recently that archaeologists are looking at entire cultures that were hunter-gatherer beforehand were quite large, much larger than we are now, bone structure, brain-wise, things like that. But since the agricultural revolution, entire cultures have actually completely died out because they went from hunter-gatherer to agriculture. So where are we now in our terms of evolution from where we were, say, 10,000 years ago to where we are now?
Well, let me go back just a little bit further, because here's the way that I understand it from the literature I've been reading, one of my favorite authors on this topic is Mickey Bendor. You can look up some of his stuff. But what seems to have happened is that humans became very much adapted to and dependent on a high-fat, animal-based diet. We're very strongly carnivorous. Our animal source food made up the vast majority of what we were eating, and because of those protein restraints on how much energy we can get from protein, that means we really had to favor high-fat animals. And the way that fat goes in animals, generally speaking, is that the larger the animal, not only is there more fat because it's a larger animal, but the higher proportion of fat that it carries. So we were always favoring these very large animals, these megafauna. And we started driving them to extinction with our hunting because that was what we were living off of. And for whatever reason, I believe it's because of human hunting, but for whatever reason, the populations of megafauna started to drop drastically. And this created what I call a kind of energy crisis. So every society that you find after agriculture started, which was around the same time that this crisis hit a peak, is some, even if they were agriculturists, if they were pastoralists, if they were hunter-gatherers who were relying on a lot of carbohydrate, or hunter-gatherers who were relying almost exclusively on meat, all of these are solutions to the problem of that energy crisis. And so a lot of people will look at different hunter-gatherers and say, this must be the way that we used to eat in our past. And I think that that's a mistake in many ways, because every hunter-gatherer society that we can find today is still some kind of cultural adaptation to the loss of being able to get access to the kind of megafauna that we had previously. So some societies might have learned how to grow some things, how to get a large amount of lean meat and supplement it with more carbohydrates in the diet. Some may have become really good at hunting for fat, or maybe we're talking about Arctic peoples who live where the animals are quite fat and there isn't much plant life to speak of. Or you might be talking about the most successful planet taking over societies that used agriculture to their advantage and are therefore using, things like corn and wheat and rice in order to make up the energy deficit that we're missing. All of those are just different ways of coping with the loss of fats in our diet. So your question is about where have we gone since that point with agriculture, and I think some of the solutions that we have found appeared to be really quite successful for a long time before the recent obesity crisis. I mean, there is literature showing that agricultural societies are more susceptible to famines because they're dependent on these crops, and maybe had nutrient deficiencies. Their brains and stature reduced somewhat, and there'd be more dental problems. But even if you set aside all that, there were societies that I think made it work pretty well. For example, Brad Marshall, who's also a blogger on diet, has pointed out that we have this, what he calls the French model, in which you have a farmstead where the farmer might grow grasses and grains, and they would feed that to the cattle and get the cattle as fat as they can, milk the cows, give the skim milk to the pigs to fatten them, and keep the cream for ourselves. So we're kind of funneling all of the fiber and the carbohydrates and the leaner things through other animals in order to get richer and richer fat sources in our diet. And that model, I think, was highly influential in the early US as well. And I think that we had relatively good health in situations like that. What has caused the downfall or the inability to make it sustainable anymore? I think there are a lot of different ideas about what's really happened. Some people think that it's a matter of the extent of refining carbohydrates. So the level of sugars in the diet has overwhelmed our ability to maintain normal insulin levels, even with a higher carbohydrate intake. I think Gary Taubes would be a very strong advocate for that position. And then in more recent years, people have been questioning whether the linoleic acid found in seed oils has been doing something to our metabolism that has decreased our ability to maintain health on a level of carbohydrate that for a few thousand years has seemed to be basically okay, even if it's not as good as it was when we were in a more meat-centric situation.
Yeah, there's more local farming. So
yes.
Yeah, they also talk about people going on a ketogenic diet. You know, they keep chasing ketones and things like that, and they're trying to get lean at the same time. Now, I've heard you say that the more fat that we carry, the more ketones we actually produce. Is that right?
Certainly in the fasted state, because there are at least two things that are going to affect the rate at which fat can be in your bloodstream besides what you add to your own diet. So you've got all this adipose tissue, and each cell in your fat tissue has a basic rate at which it can release fat for you to go to all your cells for you to use for energy. And if you don't have very much fat tissue, then the sum of all of those cells is not going to add up as much, and it might give you not enough fat. And similarly, if there's a hormonal reason, like high basal insulin levels is the primary one, then even if you are carrying a lot of fat around, if each one of those cells can only put out half of the amount that somebody who's healthier can put out, then obviously that's not going to support you very well at all. And so ketogenesis, the process of making ketone bodies in the liver, basically comes down to glucose being low, and fat availability being high. The reason that glucose being low is helpful is a little bit counterintuitive. So basically, you've got the Krebs cycle, and you're taking the substrate from fatty acids, and turning it into energy. And that's also got a rate limit. It can go as fast as it can go and no faster. And when it's going as fast as it can go, if there's still a lot of fat ready to be turned into energy that's sort of waiting backed up in the system, it's when it's waiting there that it goes down that sort of alternative pathway to make ketones. So you have to be burning fat as fast as possible for that substrate to go into ketogenesis. But one thing that can help do that is if when the fat is going into the Krebs cycle, it pairs up with oxaloacetate. So you've got these two pieces that come together, enter the Krebs cycle, and go around. And so if there isn't an oxaloacetate molecule there to pair with it, then that's another reason it will have to go off into the ketogenesis pathway. And what helps lower oxaloacetate is having low glucose. So the combination of low glucose availability and high fat availability at the same time is this like sort of magic formula that gets you high ketones. And it doesn't really matter if the fat is coming from your body or from your diet, as long as it's gotten into the bloodstream. But without fat in your diet, the more fat you're carrying and the less it's impeded by insulin, the higher you should be able to get your ketone bodies.
All right. Does that depend on the fatty acid profile?
For ketogenesis, perhaps surprisingly, the more polyunsaturated, the faster it's going to go for ketogenesis.
Wow. So a person is obese, like, and they're on a standard Western diet, and they go to a high-fat ketogenic carnivore diet, whatever, then their ketone body should be like production should be higher than like an average healthy carnivore. Then,
Someone who's overweight, did you say?
yeah.
Yeah. Normally, you would expect that all other things equal. Yeah.
Yeah. Okay. So even if you're a very healthy carnivore on a high-fat diet, you still may be producing less ketones than someone who is obese and just come from a standard Western diet then.
Yeah, and so to keep up that kind of healthy metabolic profile, if you want to still be seeing ketones, and some people might not need to. I mean, on just as a tangent, a lean, healthy person on a carnivore diet who eats a fairly high proportion of protein, and they're only getting like say 65, 70% fat, they might only have ketone bodies, measured in their blood of around 1 or even a little less. Whereas someone eating that same sort of ratio who is overweight is, if they're healthy and their fat isn't having trouble releasing their fat, you would expect to see so much contribution of fat from their fat stores that in essence it puts the ratio of fat to protein actually higher than it looks from the intake, and then their ketone bodies would be expected to be higher for that phase.
Okay. So why are we not like proteinivores? Why are we lipivores instead of proteinivores then? Why is fat so important?
Well, from a physiological perspective, even though humans are carnivores, and even though we come from a line of carnivores that's a couple million years old, that's really not very long, evolutionarily speaking, compared to the other carnivores that come from a very much longer line of carnivore species. I don't know how long felines, for example, have been carnivorous, but I'm going to make a guess and I'll probably be really wrong, but maybe it's like 10 million years. It's way, way longer than the human heritage. And so they have had the opportunity to adapt as an advantage to be able to use a lot more protein without it. They have physiological adaptations that allow them to deal with, for example, the toxic byproducts of protein metabolism like ammonia. So like a cat could get 60% calories from protein and it would be fine, it wouldn't be unhealthy. But a human really has a ceiling that's a lot lower than that. And if we try to get our full day's calories, and we can include like what's coming off our body or not, of all the energy we need, say 3,000 calories a day or whatever it is, if we try to go above say 3 grams of protein per kilogram of body weight, metabolizing energy from protein, that's going to start really messing with our ability to function. We just don't have that capacity the way that other longer term carnivores from a species perspective have. And so, I mean, that still gives a lot of leeway. Like, I think, I don't know the numbers right off the top of my head, but if I ate a couple of pounds of fairly fatty steak in a day, I don't think I would get more than maybe 250 grams of protein. And that's probably quite tolerable for a lot of people. If they're very healthy, I would say that isn't necessarily a problem. But it's not necessarily the optimal either. And I find that a lot of people, even on a carnivore diet where they're not getting disrupted by plants or carbohydrates or whatever, and even if they're very healthy, if they cut back to a range that's more like between 100 and 150 and let the remainder of their calories come from animal fats, that can be really beneficial in terms of energy, how they feel, mood, ability to make sex hormones, all the things that you would consider part of vitality. But it takes a little extra effort when you're on a carnivore diet, because most of us who come to a carnivore diet are coming from this Western diet that has a really pretty lean piece of meat on the plate, and it's able to be lean because we're getting so much energy from the carbohydrates that make up the rest of our plate. And so if you just take that same plate and you throw all the plants off it, you're left with something that's kind of unbalanced. And depending on how fat it is, you can probably get away with it to some degree. But we're not really used to finding the really fattier cuts and, just frying up strips of fat. And, if you look at say a brisket and it's got, this same amount of this lean streak is the same, width as the fatty streak. If you can imagine just eating these slices of fat, that's hard for a lot of people to get used to. And I find that people who like it and take it on and do it often do really, really well, but it can definitely be a bit of a barrier.
Absolutely. It was definitely a barrier for me at first. I do now. I love just eating fat. It's a great snack. You just fry it up and just eat fat straight away. But coming from a standard, or not so much a standard Western diet, but the so-called healthy way of eating, it was a low-fat, high-carbohydrate sort of diet. I became fat phobic, like many people do, because fat makes you fat, and so on, all the BS. But once you get your head around it, actually, you realize that your body needs it. I find it much easier to eat it now than I did at first. It was kind of difficult, actually. I hated the texture. I hated the look of it. I just didn't want to go near it. But when you get motivated.
Yeah, I have always loved fat, but even now, I do find it sometimes difficult if it's cooked to just the wrong degree, where the fat is sort of jiggly and it's not crispy, or I kind of prefer it to be either more on the raw side or more on the cooked side, but I don't like it quite as much in the middle. Sometimes I'll even put it in the fridge. Yeah, more solid. Exactly.
Yeah, I agree. I like at least crispy on the outside, and I love doing that. When I make my tallow, I sort of just make it as crispy as I can and just snack on it like that. That's good. But yeah, it does take a while to get your head around it, though. So how long have you been doing this now? You've been a high fat carnivore for over a decade now, yeah?
Yeah, I started in 2009, and everything was going amazing and smoothly until 2018. I got a couple of gut infections, and one of them was really, really bad. And after that, I continued eating carnivore for up until like 2021 or 2022, and I started doing a few experiments, trying other things, reintroducing some stuff for a little while. And it was a learning experience, and I think some of the things I did helped get my gut back into a better place. But then ultimately I had to come back to a carnivore diet because I really do feel my best that way. And so if you don't count that period of experimentation, it's been 15, oh my gosh, it'll be 15 years. No, it'll be 16 years in November. Well, it depends how you count, but yeah.
Yeah. So yeah, carnivores are not a sustainable diet, apparently. There you go.
Yeah.
So another great example of why we are carnivore or lipivores. You talk about how fat babies are, and for brain development. I mean, that's where we get the majority of our growth. So how important is it to the development of babies then?
Oh yeah, that's a great point. I love that stuff. It's so interesting that human babies are so fat. Other baby animals aren't fat like that. And even baby seals aren't as fat as human babies, relatively speaking. And so people have been trying to figure that out. You know, earlier I mentioned about how the brain is this really expensive organ and requires so much percent of our energy. Well, in adult humans, you picture like how big the brain is compared to the body, and then think about like a baby and the you know how huge their heads are compared to the rest of their body, and then you realize that the brain is proportionally way more a hog for a baby than it is for an adult. And so babies are trying to grow, and they eat frequently in order to provide that energy. But even in between their eating, they just need this massive fat reserve to keep those demands going all the time. And then in addition to that energy piece, which is already huge on its own, baby fat is composed of has a higher proportion than a healthy adult human. Their subcutaneous fat has more DHA and arachidonic acid in it, which is being used to actually build the brain, because the brain it's made up of protein and fat. It's pretty high fat, and the fats are these highly unsaturated very long chain fatty acids that are the DHA and the ARA. So that's coming up through the fat tissue. And then in addition to all that, even the cholesterol, so the brain has a lot of cholesterol in it too, because all of your neurons are surrounded by this myelin sheath that helps the signal go through more quickly in neurons, and that myelin sheath is made out of cholesterol. So there's this huge demand for cholesterol in the brain. And it turns out that the fat that is on the body of an infant gets made into ketone bodies. It has to get made into ketone bodies to get into the brain, because the blood-brain barrier doesn't allow normal fats through. It lets the DHA and the arachidonic acid through, and it lets glucose through, but ketone bodies act in humans and in adults and babies as a kind of transport form of fat in order to get by the blood-brain barrier. So in the energetic sense, if you want to burn fat for energy in the brain, basically you half burn it in the liver, send the metabolites to the brain finishes burning it. But those metabolites, the ketone bodies, when they're in this metabolite role, they also get used to be resynthesized into fat and cholesterol to make up the brain in situ, because the brain isn't really going to take up cholesterol or other lipids from the bloodstream. So it has to build all that inside, and ketone bodies are a major substrate for building that. So the fat on a human baby plays multiple roles for the development and feeding of the brain that is really crucial, especially in the first couple of years, while brain development is just absolutely skyrocketing at the same time as the body is slowly catching up.
Yeah. So the best source of these fatty acids for the baby would be breast milk for the baby.
Yeah. So breast milk has a high degree of fat. It has some ketone bodies, I think, just like the umbilical cord does as well, the placenta. And it has some carbohydrate, some of which are used to, there's specific types of carbohydrate that are used immunologically in the gut, but also some just carbohydrate that gets used by the brain. And at the same time, in the last trimester, and then also in the first 6 months or so after birth, the baby is also laying down a bunch of fat tissue to get even fatter to help it get through the last period of development as it's weaning onto more regular foods, so it has that extra fat to continue to contribute all these nutrients through the sort of post-weaning area, time period.
Yeah, so I'm just wondering that those carbohydrates in breast milk would help the baby to obviously stay fatter and produce more ketones to feed the brain. Yeah.
Yep.
Yeah. So, I mean, it's essential for the development of babies. You know, how essential is it for, you know, as not breast milk, but, you know, fat, cholesterol, how essential is this to the brain as we get older?
It's really critical. I mean, so obviously we as adults don't need to carry as much fat, relatively speaking, on our bodies as babies do. And that's partly because of the relative size of our body compared to our heads, the rest of our body. But we still do need to be able to have cholesterol and fat and nutrients for the brain. Stephen Cunnane has done, and many others have done experiments figuring out that good access to ketone bodies can really help with cognitive decline. So I would say that, you know, we're in this weird position that we talked about in the beginning, where we have figured out how to get a steady supply of carbohydrates in our diet that can really make up for a lot of the energy deficit that we would normally have gotten from fat until very recently. And the brain knows how to make energy out of glucose, and our cells know how to make energy out of glucose. So it's not necessarily a bad thing, but I can't help but think that because we had such a long period of evolutionary adaptation to spending most of our time in ketosis, that and this goes along with the brain benefits that we see when people go on a ketogenic diet. Normally we're comparing it to somebody who's struggling on a high carb diet. So we've got like 3 different situations. We've got high carb dieters who are doing pretty well. We've got high carb dieters who are starting to suffer from all kinds of decline or disease in the brain and the rest of their body. And then we've got people who go on low carb diets to try to address these problems. And what we don't have enough of, I think, are people who are just already healthy and aren't trying to overcome some problem with their energy use where they can't use glucose as well anymore. And I think it would be really, really interesting to see, you know, obviously, if you go on a ketogenic diet and you're able to use ketone bodies for your brain, when your brain was suffering from inability to properly use glucose, then you're going to get benefit. But my bet would be that you're still going to get a huge benefit from being in a ketogenic state most, if not all of the time, compared to a high carbohydrate state in terms of cognition. We can already see, for example, that it affects your sleep. And so when you're on a ketogenic diet, you get more energy in the brain, and that allows all kinds of repair, all kinds of focus and cognitive ability. I really think that it would be wonderful to have a lot more studies that are not just in fixing diseases, but in making humans be as, as healthy as they can possibly
As
be.
optimal as possible, yeah.
Yeah.
But the difference being that the brain can get energy, the body can get energy from glucose, from carbohydrate, but it can't get nutrients. Like, for example, before I was diagnosed, I was very fit, and I used to do marathons, triathlon, all sorts of sports. I had a high protein diet, and low fat diet. But obviously, for endurance sports, you also carbo load and eat a lot of carbohydrates and that sort of stuff. I had plenty of energy, but I was very sick and ended up with stage 4 cancer.
Oh, no.
Yeah, well, actually, I was stage 4 twice in 2 years with follicular lymphoma, and I spent 3 years going through chemotherapy.
What an ordeal.
Yeah, it was a bit of a struggle, but I had plenty of energy. Like, even like a week before I was diagnosed, I was still in the gym. I was still very active doing sport and things like that. So I think there's a very big difference. Like, the body can still have energy, but it's just not getting the nutrients that it needs to maintain health. So that, I think, to me, is the difference between being on a carbohydrate diet or a high protein diet to a high fat carnivore diet.
Yeah, and I don't know what kind of, did you do a meat-based or carnivore diet, or was it more just a regular ketogenic diet?
It was just a regular ketogenic diet. I was, I'm a strength coach. I was working in the fitness industry, so it was very much a processed sort of protein diet as well. Chicken breast, very lean, fat-free, very low-fat diet. My carbohydrates is just rice and vegetables. So, the perfect clean diet, basically, for the so-called fitness industry. But that, I mean, you get problems with too much protein, obviously, like rabbit starvation, those sort of things. I think it's just lack of nutrients from fat. I think even if you have a high protein diet, if you have a higher ratio of fat in your diet, you're still going to be healthy. Yeah. But the difference is when you can still have energy, like, because you're eating carbohydrates all day, or you're eating all day. Like, I was eating 5-6 times a day. So I had plenty of energy, but still be very, very sick.
Yeah, and the other thing to consider with a high carbohydrate diet is you are really creating a hormonal response to those carbohydrates over and over and over again. And especially if you're talking about insulin itself, I mean, it's important, it's necessary, and in order to have cycles of growth, I mean, you can't only be catabolic. You need to have some growth. But at the same time, if your insulin load is just over and over and over again and you never catch a break, then your body doesn't have the time to do things like clean up, like spend a lot of time in a more autophagic state where you're getting rid of cells and cell junctions and proteins that are not functioning as they should. And I think the body just benefits, even if you're not on a low carb diet all the time, to have these periods where things are more focused on cleaning up and restoration rather than just build all the time.
Yeah, definitely. Yeah, I was very much against fasting at the time too. So where do you stand on fasting then?
Mixed. I have mixed feelings about fasting. Fasting can obviously be really therapeutic, and almost miraculously so for some people. I think that for the most part, the benefits of fasting have to do with getting into a deeply ketogenic state, which obviously doesn't require fasting on its own. The other thing is that sometimes people can have something in their diet that they're either really intolerant to or is adding a toxic load that they may not realize. And so even if you think you're eating really well, and even if you're eating ketogenically and eating what you think is really good, you might find additional benefit to fasting if something in your diet is causing an inflammatory response somewhere. So those are the main two things. But I do think that even with all that, I mean, for the most part, many people probably don't need fasting if they're doing those things, but some people can get extra benefit in fasting if a couple of things are happening. One is if they just can't get their insulin levels down. Sometimes just a day or two of fasting can go a long way to bringing insulin levels down low enough to get all those processes happening that eating ketogenically just hasn't been ketogenic enough for them for whatever reason. They've got some kind of immunological response going on, or their body's gotten sort of locked up metabolically. I do worry about prolonged fasting because I think that too much time without contribution from protein, you can put some of your organs at risk, because there's just always constantly turnover in all of your tissues, and the tissues that have the higher turnover rates are the ones that are not going to get built back up properly if you're doing fasting too often or too long. And so I worry about that a little bit.
Yeah, that's fair enough. I mean, we still need to regenerate, and we need a food source for regeneration, sleep, and things like that. So I agree. Right. Fasting it can be a useful tool, but it's not something you do, all the time, and especially prolonged fasting.
People can get crazy about it, and just like, it's not quite the same as a prolonged low calorie intake. Like if you don't do any fasting, but you undereat deliberately day after day, week in, week out, your metabolism's going to freak out and start like, you're going to have to give up some of the things your body wanted energy for, and your metabolic rate's going to compensate in a bad way. And one thing that's nice about fasting is that it puts all that caloric restriction all at once, so that if instead of eating 500 calories less every day for 5 days, you eat 2,500 calories less one day, and then it gets all over with. The next day you eat normal again, and your metabolism will be less likely to start adapting down. So it can be advantageous in that way. But then some people, they just fast and fast and fast, and it's never enough, and they don't really do their refeeds long enough, and so they're fasting more than they're refeeding, and in the end it starts to look just like long-term caloric restriction for them and has all those same problems.
But people always, I mean, people fixate on certain things, like when they go, for example, they focus on the protein intake. Oh, I have to get a lot of protein. It's a high protein diet.
Yeah.
And they just fixate on that, and it's really difficult to change their mind. This is something I keep telling people, that think of us more as lipivores, because we are, we should be getting majority of our nutrients from fat.
Mm-hmm.
Fat is just so nutrient dense, but there is still like we were talking about before, a bit of a phobia about eating fat. Fat has more calories than carbohydrates and protein, so it makes you fat. That's ridiculous nonsense like that. it's something that I think is going to take time, unfortunately, to change people's minds on. Yeah, and try and get them away from that fixation. But yeah, we all go through it, I guess. You know, I was the same. So yeah, I can understand. You said like we are lipivores. We evolved, not just because, but to eat a high fat diet. Is that different to anything else on the planet? Like I spoken to Dr. Peter Ballester about this. He said that no life on Earth has a low fat diet.
So what he's getting at there is that all of those herbivores, when they're eating fiber, the first thing that happens to the fiber in their gut is that it's eaten by bacteria that then give off short chain fatty acids, and the short chain fatty acids are the actual caloric content that the animal is getting. So the animal's not getting anything out of the fiber except for it's getting it exchanged in their guts for fat, and so they're getting that fat. But I would add one caveat to that, because there are basically the most important short chain fatty acids are butyrate, acetate, and propionate, and most of those fatty acids are in turn being used actually for gluconeogenesis, to turn back into glucose, actual glucose, which is then how that animal gets most of its energy. So if you take like a cow that is getting most of their diet is fiber, and then Peter's point is, well, and then that mostly turns into fat, so their diet is actually really high fat, but then they immediately turn that into glucose, so what their whole body is using is still basically a glucose-based metabolism. They're not in ketosis, and if a cow is in ketosis, that's actually a medical problem that a vet would have to try to correct. So that's actually the case for almost every mammal that we know. They're either an herbivore that's getting most of their diet is fiber that turns into short chain fatty acids that turns into glucose, and they have a glucose-based metabolism, or they are a carnivore that's eating a mix of protein and fat, and they're turning that protein into glucose by gluconeogenesis, and they also therefore have a glucose-based metabolism. And in both of those cases, it's from gluconeogenesis. It's not from straight digestible carbohydrates coming from the diet. Almost no mammals have more than, say, 10% or something of glucose that's straight up coming from the diet. It's all gluconeogenesis in one form or another. There are some exceptions, obviously, like, say, fruit bats, I think, get most of their calories directly as glucose and fructose from the fruit that they're eating. But humans really are quite unique in this ability to, as long as we're not talking about the recent agricultural high digestible carbohydrate diets that we've been eating for a few thousand years, we are able to not only get most of our energy from fat, but also be in this ketogenic state, which, I've looked at many different species, and many species can't get into ketosis at all. That would be the case for like whales and dolphins. They have a genetic mutation that doesn't allow it. And the remainder can get into ketosis, but as soon as they get adequate protein, they stop being in ketosis. So for humans, there's this tolerance of protein. We can eat, for a healthy human, the number that I'm seeing seems to be we can get about twice as much protein as we actually need. and we will still stay in ketosis as long as we don't have carbs in the diet. Now, people who have protein intolerance from having been diabetic or other situations might not be able to do that and might need to stay closer to like the bare minimum to be in ketosis at all. But I find it really quite astonishing because any other animal, as soon as they can start running everything on gluconeogenesis, they do. And humans seem to be unique in perpetuating the generation and maintenance of high ketones in the blood in order to feed the brain. And I do think I think it does come back to our brain needs and our unique situation in terms of the brain for that.
Yeah. So, I mean, we're unique in many ways. We are the hyper carnivore, we are the top of the food chain on the planet, and the most dominant. So, yeah.
It's really incredible how we change our environments. Like lots of animals might do things like building a nest or changing things in their environment to make it habitable, but humans are just like incredible amount of externalization of our habitats.
Yeah. No other animal can do what we do. So it's, I mean, you can see it all around us that the proof is there. So now these other animals you're saying that they're all like glucose energy sources. They use fiber. What are your stance on fiber in the human diet then?
I don't think it adds any particular benefit. I think that when you look at epidemiological studies that are looking for some kind of signal of health benefit from fiber, there's no way for them to untangle the amount of fiber that they see in the diet from the reduction of processing on the carbohydrates that they're eating. So really it's just a signal of the carbohydrates that they're eating are less processed. But if you take carbohydrates out of the picture entirely, then there's no extra role for fiber. It doesn't add anything.
Okay, so summing up, like these are all reasons why we are hyper carnivores, why we are at the top of the food chain, and why we have developed to where we are on the planet then.
Yes, I mean, that's what I think. I think that all the evidence points toward humans having come from a long line after we split from our closest relative line to more and more carnivorous sort of behavior that may have started with scavenging and very high fat, high animal fat intake that allowed us to increase our brains, and then our brains were able to help us to increase our ability to make use of such tools in a positive feedback cycle, and that all of this went on for a very long time, making us into a really quite unique niche because we don't have the long carnivorous heritage that other carnivores that we might try to compare ourselves to did. And we also, because our brains were developing to such an extent, we were able to make up for the fact that we didn't have things like as much tooth and claw in order to catch our prey. We were able to rely on our fast developing brains for figuring out ways to do that go beyond body parts that we couldn't force to evolve in time. We could just we could make use of our intelligence to build things and to cooperate in order to get us the nutrients that we needed to support the continuing development of the brain. And it was only really this crisis of running out of the right kind of food that we had to sort of, figure out a way to survive on a different kind of diet for the last 10,000 years or so. And we're still dealing with the consequences of that. And if we could learn to get more fat and not be afraid of it, for one thing, and take advantage of things that we've done in the past, like find it for a second, domesticating animals that have the highest potential for growing fat, then we can take something like cattle or pork and get a high fat diet, even though the megafauna are gone, and we shouldn't try to interfere with that if that's a viable way for us to get what we need.
Yeah, regenerative cattle farming or ruminant farming anyway would be I think a far more efficient way to farm or to get that source of fat.
Mm-hmm.
And certainly more beneficial to the environment than monocrop farming and things like that as well.
Yeah,
So,
yeah.
But that's a whole other topic. It's Anyway, thank you very much. I really appreciate you taking the time out to speak with me today. This just amazing information. And for anyone that's listening to this, when I release it, have a look back at Amber's presentation. She has many of them. They are absolutely wonderful, full of brilliant information that you can really learn a lot from. So thank you very much again. I really appreciate it.
Thank you, David. I had a really nice time talking to you, and I appreciate your invitation.